Good afternoon, and good evening. Okay, so this is Sachin sir again, and we are here when doing what? Again, we are starting the score. Okay, so welcome you everyone for the grade 7. Okay, that is the score questions we are going to do. Okay, and we all know why we are doing this. Yes, everyone. So that is the reason for doing the preparation for the scores scholarship examination. Okay, and we can win the 100% scholarship also, 2.5 crore of cash rewards, and the very best thing is the NASA trip that I like the most, and every time I say it. Okay, then the exciting gadgets and the 100% scholarship we getting my point. So these are the such a good things which we are getting it right now from whom? From the Sri Chaitanya Learning Institute. Okay, so right now we are on the Sri Chaitanya Learning Institute and YouTube channel. Right now we are doing it. Okay, so this is for the score examinations. Yes, now again, coming to the main part, don't forget the dates. Don't forget the dates here, everyone. Okay, now as you can see, the exam dates are 28th of September, okay, and 12th of October. Clear? That's the 28th September and 12th of October is the examination date, as you can see, and you can register on the srichaitanyascore.com, and the link is being given in the description, everyone. Link is being given in the description. Okay, so now we all know what we are doing it, right? Yes, this is the part first where we are going to discuss about the questions, of physics which has been going from the grade 7 in the paper. Okay, so that's a part 1. Previous year questions also are being there with the concepts and everything. We are going to do these one parts of it. Okay, so everyone's ready now? Yes or no? Everyone's ready with me? Okay, so just if you want to, you can just take the notebooks for solving the some questions, and you can just do with me, and you can just reply in the chat box. Okay, also, so here we go. So we are discussing the class 7 physics previous year papers score questions. Okay, so now here comes the question number first, everyone. Here comes the question number first. So let's solve. Let me select the pen. Okay, so the question number 1 is being saying the image formed by the plane mirror. Image formed by the plane mirror is always real, always virtual, can be both real and virtual, none of these. Very easy one. So previously also we have been talked about what? We have been talked about the properties of the plane mirror. Let's see it one more time. That is the properties of plane mirror. Okay, so in the properties of the plane mirror, the first one is the image formed by the mirror or the plane mirror is virtual, and virtual images are always erect. That means upright. Yes, now what is this upright here? So suppose if the object is being like this is an extended object A and B, and image also formed in the form of this only A dash and B dash. Okay, like for the real one, if we see it, for the real images are inverted images. Real images are inverted images. So suppose if I just have the object like this A and B, so image formed will be like A dash and B dash for the finite one. I hope so it's been clear. So always the image formed by the plane mirror is always virtual. Okay, now if we talk about the mirrors, so mirrors have been segregated into two parts. One is the plane mirror and another is the spherical mirrors. So the spherical mirrors, we have it in the spherical mirror. If we talk about, we have the two parts. One is called the concave and another one is the convex. Yes, and one is the plane mirror here. Now if you talk about concave and convex, so concave and concave, B forms how many ray diagrams are there? 6 ray diagrams, and out of these 6, 5 ray diagrams forms the real and virtual image, whereas the one which is being left, that is between pole and focus. Okay, it's a magnified one, and we get it virtual and erect. Okay, so I am just telling this one part of the plane mirrors and all, so it will give you the quick revision of the topics also which we have been studied previously, and if the question comes from the concave or convex, you know it. So how many ray diagrams? 6 out of 6 ray diagrams is there in the concave. It's for the mirror, not for the lenses, remember. It's for the mirror we are talking about. Okay, then for the convex, if we are saying for the convex, it forms 2 ray diagrams. and both the ray diagrams form the virtual and erect. Okay, and these are diminished, or we can say both the images are smaller than the object, but here you don't get the smaller than the object. Here are the conditions. There are the 6 conditions which are being, like when the first one, when object at focus, at infinite, first of all let's take for the infinite one, object at infinity. Second, that is beyond C. Okay, then the third one is between C and F, that is the center of curvature and the focal length. Fourth one is at focus, that is F. Then the fifth one is, which one is being left? Yes, at C is being left. Yes, so at C also is being there. At C, that is center of curvature itself. And the sixth one is which one? Let me write it again. Okay, in a sequence. Then it will be quite good. So you won't get confused with this one part, everyone. Okay. So till here we got it. So first one, from the infinite we are going from. Okay, we are going from the infinity. Okay. So first one is at the infinite. Then beyond C. Then third one is at center of curvature itself, that's the same size one. Okay, then the fourth one we have between C and F, that is center of curvature and the focal line. Okay, focus point. Yes, focus. Then you have the fifth one, that is at focus itself, and the last one is between pole and focus. Okay, so these are the 6 ray diagrams for the plane mirror, for the concave mirror. Okay, for the convex you have the 2 parts only, that is one is at the infinite and another one is at the, which one? See here, like if I just draw it for the this one, so one is for the infinite and one is somewhere from the finite distance from the pole itself. Okay, from the pole itself. Okay, I hope so this one is being clear to everyone. Yes, this one is the clear to everyone. That is the one which we have done. Now the next question comes on the screen here. Now what's been talking about? It's been telling us a ray of a light strikes 2 mutually perpendicular mirrors as shown in the figure. As you can see, sometimes what happens, they won't give you the ray diagram, they won't give you the diagram, they just simply say 2 mirrors perpendicular to each other. Just remember we have to draw it like this. Just remember we have to draw it like this. Okay, see, got it now? So what has been saying, the ray of a light strikes the 2 mutually perpendicular. See, mutually perpendicular, that means for suppose this is a mirror 1 and this is the mirror 2, so 1 is perpendicular to 2 and 2 is perpendicular to 1, that is both are the same, that's called the mutual perpendicular. Like you have the mutual friends. Okay, so like this is a mutually perpendicular to each other. Find the total deviation of the ray of a light after reflection from both the mirrors. From both the mirrors it's been asking, that means the light has been incident towards this plane number 1 and then it gets reflected in this direction. Okay, so 2 things we will do now. First I'll give you the answer for this one, what will be the answer for this one. Second, I'll let you know how to find or calculate the angles with respect to it. Okay, so it will help you out. Okay everyone, so now if the light ray comes here, suppose this is the normal, so it just get, just a second, it just get reflected towards here. Then if this is the normal, so it just get like this one. Okay, so it has been going in the same direction from where it has been came, and it always happen this only. Okay, clear? So according to the question, the light ray is coming here, that's the incident ray, then after reflection from first one goes to the second, and for this one it becomes the incident and then goes to the reflected one, this. Now it's been asking what is the angle or total deviation of the light ray. So see, both the rays are in the same, but only the thing is the direction is being opposite. That means what is the deviation? Obviously that is 180 degree, simple. The deviation is 180 degree. Now the question how it changes now. Sometimes what they will do, instead of deviation, just a second, yes, instead of deviation they are going to give you this angle, suppose 30 degree, or maybe they will say you the ray of a light strikes the two mutually perpendicular mirror at an angle of 30 degree from the normal, angle of 30 degree from the normal. So like this, it may becomes like this, and with the normal it may be making the angle 30 degree. Either it will be forming like this, or you can take it like this also. So this is 30. Any one direction you can take it, that's totally depend upon you, unless the diagram is not given to you. Okay, so either you take it the first one part like this one, or this one if the angle they have given. Now suppose in this only they have given you 30 degree. So how will you calculate the other angles? So see, we all know that angle I is equals to angle R. Yes, that's the laws of reflection. So angle I equals to angle R, so this will also be the 30 degree now. Clear? If this is 30, then just check it here. This complete one is 90. 90 minus 30, this will give you the 60 degree. Okay. Now, since these two mirrors are perpendicular to each other, yes, these two are perpendicular to each other, so it will be 90 degree. Now, can you see, this is 90, this is 60. So this will be now, obviously this is 90 and this is 60. This will be now how much? Obviously that will be 30. Yes, that will be 30. Now if this will be 30, so see, so this is complete is 90. 90 minus 30, this will become 60. If this is 60, so angle I equals to angle R again. This will also be 60 degree. Got it? So now like this also, if any of the angle which has been given to you, you can find the other angles too. So with the single question we have done the two things. One is the one which has been given to you, and another is the one which we have been added some points into it. Now if they didn't give you the diagram, you can go for with that approach. If they have given the diagram, go with this. Okay, I hope so it's been clear. Yes, everyone, clear? So now this has been done. Let's move to the question number 3. Let's move to the question number 3, everyone. Okay, so particle moves on a circular path of radius r if the particle covers 60 degree. If the particle cover 60 degree on a circular path, then find its displacement. We have to find its displacement. Very easy. Okay, not that much tough. Okay, see. So particle moves on a circular path of radius r. Suppose let's draw this is the circular path we have drawn of radius r. This is the point. This is the radius r. Okay. Now let's change the color here. This is O, for example. Okay. If the particle covers 60 degree of the angle, 60 degree means this has been the one, and then it moves 60 degree like this. It moves 60 degree like this. So for example, it moves 60 degree like this. So this angle is 60 degree. Okay, done. Got it. So this is 60 degree. That means the same has been there. If this is the radius r, so this will be also the radius r. Okay. Now, so we need to calculate the displacement. Just a second. Yes, we need to calculate the displacement over here. Okay. Now you can see a triangle seems to be there. Okay. Now we have to calculate this one part. So let it O. This is be A. This will be B. Okay. So now we have to calculate the AB. We have to calculate displacement, that is AB. Okay. So what is this AB here? Clear? Now since you can see we have OA is equals to OB. Okay, we have this OA is equals to OB. Yes, we have OA is equals to OB. That means suppose if you have a triangle here, for example I have drawn like this only. This is the side which is be given, although it's not seems to be a accurate one. Yeah, but suppose this has been given like R, this has been given R, this is 60 degree, for example. Okay, and these two sides are equal. These two sides are equal. So we can say these two sides are equal, then it forms isosceles triangle. Yes, it forms the isosceles triangle. Clear? Now, since it's an isosceles triangle, so suppose this is theta 1, this is theta 2. So the angle theta 1 is equals to angle of theta 2. Now what is this theta 1 and theta 2? That is angle OBA is equals to angle OAB. If these two angles are equal, then the sum of the whole triangle is 180 degree. So that will becomes now what? That is theta 1, theta 2, 60 equals to 180. These both are the same one, so that will be like 2 theta plus angle 60, 180. So it will form what? 2 theta equals to, I'm writing it directly now, minus 60. So it will be 120. So theta will be equals to now 60 degree. That means what we got it here, suppose this is a triangle one only part. So we got this here like, okay, this is 60. This one also we got 60, this one also we got 60, this is R, this is also R. So see, since all the angles are 60 degree, so they are forming what? They are forming the equilateral triangle. They are forming the equilateral triangle. So third side, that is the one which is OB and this is A. So this also, so that means OA is equals to OB is equals to AB, that is equals to R. Okay, so like this we have been solved here. Clear everyone? So this is the one approach we can do. Now another approach also you can do it, but we are not using that one like the Pythagoras and all we have to apply, but that should be the 90 degree one angle should be there. Okay, so instead of that we will be using the cos theta one angle. So cos theta we will be using like 60 degree for it. Okay, so we will be using like AB square is equals to OA square plus OB square minus 2 OB OA cos 60, then we can do it. But that is the proper one, we can use it, that's geometrical shape ones and okay, the triangles and all, we can do that. Clear? I hope so this is clear. Okay, so this is the displacement which we got it the same. So option number D is the correct. Let's change the color. Option number D is the answer. Okay, clear everyone? Okay, chalo, let's go to the next one now. Here we have the another question. And that's what? A car moves with a speed of 40 km per hour. See, 40 km per hour for 15 minutes. Okay. Then with the speed of 60 km per hour for another 15 minutes. Okay. Then with a speed of 48 km per hour for 10 minutes. Then with the speed of 30 km per hour for 20 minutes. It's an easy question, guys, and we have to find the average speed of the car, not the velocity. First of all, we need to find the average speed of the car. We can do it, it's very easy. Now if you are watching it, like suppose if you are seeing it for the which part, like offline also, and later on you'll see it, just take your time, pause the video and just take your time and try to solve it out. Okay, and then put the answer in the chat. Okay, clear? So the car moves with the speed, so one by one we'll be solving it. So car moves with the speed of, so first of all what we require, what is the average speed we have to find now? So V average is equals to total distance traveled upon total time taken. This is the formula we wanted, but we do not have the distance. Yes, we have the speed and the time. So let's do it. Suppose it moves from here to here, that is with the speed of 40 km per hour in 15 minutes. Okay, then another again they moves 60 km per hour for again 15 minutes. Then again it moves for 48 km per hour for 10 minutes. Okay, and then it moves 30 km per hour for 20 minutes. This is the complete motion of the object. Okay, this is the complete motion of an object. Now when you wish to convert it, now let's find out what is the distance has been covered during that particular duration. So see it here, A to B, C, D, E. So for example, A to B, let's do it. So that's the speed is 40 and the timing is 15 minutes. So we can change it into R. 15 divided by 60. Yes. Yes. Yes or no? So it will be like 3, or you can do directly that's 0.25. Okay. Let's do that. 0. Let's 15 by 60, that is 0.25 R. Okay, that is the time we got it. Now the distance we will take it out. How the distance will be calculated? So the distance for AB will be equals to speed into time. So speed is 40 into time is 0.25. Yes or no? That's 40 into 0.25. Do it. See. Okay, clear. So 40 into 2.5, when you solve it, how much you will get? Just take out the ratios of it. That will be, if you want, that 100, or directly you can multiply. So zeros cancel with the 0, then 5, then 2, then 2, 2 5s are 10. That is 10 kilometer is the distance traveled by AB. Clear? That's the distance traveled by the AB. Then we find it for B to C. Let's find out for BC. So BC will direct, that is 15 made 0.25 only. So 60 into 0.25, directly we are doing it. The same thing we have to do. Okay, see it, the same thing we have to do it. Okay, so it will be like 100. Okay, zeros cancel out. 2, 3, 5, 5 3 are 15. That is 15 kilometer. BC is 15 kilometer. So AB we got, BC we got. Let's find out for the CD. Let's find out for CD. I'm doing it here, CD. So CD will be like 48 and 10 minutes. So 48 into 10 divided by 60, it will be 0. So 6 into 48, that will be 8 kilometers. So CD we got 8 kilometers. Okay, clear? This is also done. Let's do it for the D to C. Sorry, A, B, C, D, E. Sorry, D to E. Okay, so we have the DE. That is again how much? 30 into 20 by 60. Zeros cancel. 1, 2, 10. So DE will be equals to 10 kilometers. So here we got the complete distance traveled by the body like this. Okay, in this only formulas, the question may change, but the formula will remain same. These are the process, you need to change it. Okay, we also know it one thing, and that is what? While changing for kilometer per hour, 2 meter per second, we have to multiply by 5 by 18. Okay, whereas whenever we have to convert from meter per second to the kilometer per hour, we have to do 18 by 5. So I hope so this one has been clear. Now total time taken, total time will be, so let's write total time will be like 0.25 plus 0.25 plus it will be like 1 by 6 plus, and that will be like 1 by 3, that will be 20 by 60 now. So it will be 1 by 3. Okay, so see, sometimes what happened, the question is very easy, but what happened, if you want to add it, you can add it, it becomes very easy. But one more thing we can do it. If we add the minutes also, let's see it. So that's 15 plus how much? 10 and 20. 10 and 20. So it becomes 30 and 30, 60 minutes. 60 minutes is equals to 1 hour. And that is also becoming 1 hour only. So these two things are coming same. Okay, so total time we got it, total distance. Total distance will be like V average. That will be AB plus BC plus CD plus DE upon total time is how much? 1 hour, which we got it already. Just put the values. How much? 10, 15, 8 and 10 divided by 1. So just add it on. How much you will be getting it? 10 plus 10, 20, 20 plus 10, 30, 30 and that 48, and 5 plus 43. So that will be 43 upon 1, so it will be 43, and that's the average speed. So kilometer per hour, we are getting the answer. Okay. See, just I was doing it in the step-by-step process so you can understand. Otherwise, we can do it directly also. We don't have to write all these things in the MCQs paper, okay? So be with the speed when you're having it, okay? So you don't have to write it like this. You have to draw it or something down. You don't have to do it. Just the explanation one part I'm giving you, that's why I'm saying it, okay? Otherwise, directly just put the values and do it. Simple, nothing. No writing and nothing. Otherwise, it will take the lots of time for solving it. Okay, so you won't be able to do it the question. So the answer is 43 kilometers per hour. Now, this is done. Let's change the question. The question has been changed into the magnetism one part. Okay, here we comes the magnetism, and here we are talking about the electromagnet part of it. Okay, here we are talking about the electromagnets. Okay. Now, what is the electromagnet? It based on the principle of the solenoid. It based on the principle of the solenoid, and the thing is what? The thing is what which I am writing it here. See. A current set it by the Oersted. Okay, that is the name is Christian Hans Oersted. The name of the scientist Christian Hans Oersted, who gave and who told us about the thing. Actually, he is the only one. Okay, many theories and the philosophies are going on, keep going on. But yeah, right now we have to move to the part Oersted. A current carrying conductor introduces magnetic field in it. So on the basis of this one part, a current carrying conductor introduces the magnetic field in it. What we have done, we have made the solenoid, and solenoid was the principle of the electromagnet. Simple, nothing is the electromagnet. Take the iron nail, take the copper wire, start winding over it till here you reached. If you want to put it till here, put it till here. So one wire from the starting one and from the end, put it to the cell or the battery. Your nail starts to work as a electromagnet. Very simple, which you can make it at your home. Now if you want to increase the magnetism, wind it up into the back, then you will have the two wires at the last here. Okay, just put the cell or the battery there and you will get it. Like see, for example, if I have the nail here, okay, and let's have the winding over it of the copper wire. So the wire is being like this, I have taken, and see, and take it from here. Now just use the battery here, and here we go, positive and negative, that is the higher potential and the lower potential. The current will start to flow in this, and when the current starts to pass through this copper wire, it will start to behave like a current carrying conductor as introduces the magnetic field in it. So it starts to behave as a, or if you have the iron nails or something which is of the iron or the iron dust or something, it will start to attract depending upon the how much amount of current and the number of windings you have done. So if you increase the number of windings, if you increase the number of winding, or if you increase the current into it, the magnetic field will start to increase more. The more strength you will get. Simple logic, very simple. Okay, practically we have done. Practically you can also do it. If one nail is like this and another nail you have the wiring like this, and then you have this one, two wires. So what has been done? This has been more coiled. This has been more coiled. Now, second thing, if the wiring has been like this, so between them, the distance has been there between two coilings, and another wiring has been like this. Very close, very less distance. Very less distance means more strength of the magnetism. Remember, more strength. Because question may not come only this one. It may be comes from this part, whole of it. So that's why I'm taking each and every of thing. So the distance lesser, more magnetic field. Distance is more between the two coil or the two round, lesser magnetic field. Number of windings will be more will be the strength. The amount of the current flowing into will be more strength. That means the magnetic field is been increasing. Magnetic field is been increasing by increasing the current. So we can say the magnetic field is proportional to I, that is the amount of the current. And magnetic field is also proportional to the number of winding, that is N. Suppose a coil which has the 50 rounds of the coil and another has the 100. So obviously the 100 one having the more amount of the strength of the magnetic field. V is the magnet, which is the strength of it. Okay. Then if the coil have this distance R, so that is the inverse. That is the inverse. Between the two coils, if the gapping between the two coils, two round of it, okay, helical path, two round of it is lesser, more strength. If it will be more, lesser will the strength. That's why it's the inverse of it. Okay. We have the formulas and all. Okay, for the electromagnet, for the solenoid and everything. Okay, we don't have to go it for that right now. Okay, because it will be using the mu naught Ni and something. So that is the permeability upon R. Okay, so that we don't have to use it. But now on the basis of these things, now things has been clear. So we have given A, B, C and D. It's asking among the electromagnets shown below, which one is the strongest one? So as you can see, number of turns, if you see 1, 2, 3, 4, 5, 6, okay, 1, 2, 3, 4, okay, 1, 2, 3, 4, 5, 6, 7, 8. See, you don't have to go it by counting it. I'm just telling you, okay. Then more thing is see, battery, single cell, double cell, triple cell. More cell means more current. The current is also high in this. I is also high. Then count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 20 rounds. That is B is proportional to N. B is proportional to I. See it here. And you can see the distance between the coils. So you can see it here, the current, the amount of the battery which has been using here is also more. This has been more. So the strength will be more for the D1. Okay, so I think the question will come from the magnetism or magnetic field from the electron or the solenoid or something. You can do this task. Okay, clear? Now, so this is the part of it. Now let's move to the next question, everyone. Let's move to the next question, and that is a question number 6. We have it. Okay, so again from the mechanics part of the motion and all. So a train traveling at a speed of 54 km/h has to stop at a station. Okay, that is 500 meters away. Has to stop at the station that's 500 meters away from it. How much retardation? You know what is the retardation? A negative acceleration is called retardation. A negative acceleration is called retardation. Required for the same. So train traveling with the speed of 54 km/h. So that is the C. It's been traveling with the speed of 54. Okay, and has to stop. That means the train is already in motion, and after some time it will stop. So initial velocity will become. So you have the initial velocity that is 54 km/h. And final velocity will be 0 because it needs to stop. How much away? 500 meters away. So distance is being given 500 meters. It's asking how much retardation is required for the same. See, your velocity is being changed. It's from higher to lower, it's been done. The velocity is being changed from higher to low. That is from 54 to 0. So obviously we will be having the negative form of the acceleration, then only it will be stopped. Now that's the reason which we have given to you. Okay, so now you have the U, you have the V, and have the S and the A. So we have to use the equations of motions. We have to use the equation of motion. So if you know it, you can just write it down in the chat box, everyone. Equations of motion. So we have the first, that is V equals to U plus AT. Okay, that is the first equation of motion for the uniform acceleration. Remember, for the uniform acceleration. The second one we have it, that is S equals to UT plus half AT square. And the third one we have it, that is V square equals to U square plus 2AS. Now we want the A, that is the acceleration. And the best thing to do these type of the questions is always write the given. So what is given to us? These are the things given to us. What we have to find? This we have to find. What for the formulas we are having? These are the formulas we are having it right now. So which one we will apply? Just see it. Do you have T? I don't have T. I don't have A. Two variables unknown. We will not use it. This one, SUT half AT square. Again, T. I don't have it. S also I don't have it. So this also I don't have. This also I don't have. Two variables unknown. Again I cannot use it. Getting my point? Again I cannot use it. So what to do? Now third one, v we have, u we have, 2 is the common, that is a number, a we have to find, and s we have it. Only single variable is unknown. Only the single variable is unknown. So we can use simply this one. Let's use this one. So from the third equation of motion, that is v square equals to u square plus 2as. Now v is 0. U is how much? 54. Again, now here comes the click. This is given in kilometer per hour. This is given in meter. And the answer is given in meter per second square, meter per second square. That means everything is given in the SI unit. Only this speed which has been given is not given in the SI unit to us. It's not given in the SI unit. So what we'll do? Told you. Remember, note. Whenever you want to change kilometer per hour to meter per second, always multiply by 5 by 18. You can do another thing also, divided by 1000 upon 3600, but why to do it? Already we are having the short trick. Okay, then meter per second to kilometer per hour, so it will be 18 by 5. Right now what we have to do it? We have to convert the 54 into the meter per second. So what we'll do it now? So here I am just using this one. Okay, so that is u is given 54. Can anyone tell me the answer in the chat right now? Anyone? Or later also you can write it down. Very easy it is. So that will be like 54 into 5 by 18. That goes by 3. So 15 meter per second. Simple. That's a 15 meter per second is the easiest. Got it. Okay. Now put the values. 15 square 2 into a. And that is the s is how much? 500. Given. Done. We have to find the retardation, that is a negative acceleration we have to find. So if our answer should be coming in the form of the negative, that's what we wanted. Okay, so see it here. Suppose this is 15 square is 225. You should know it. That's a 0. 225 plus that will be 1000 a acceleration. Now it goes to 1000 a is equals to negative of 225. So a is equals to 225 negative upon 1000. The zeros when put it upper, that is 10 to the power minus 3. So if you write it in the way of it, so it will become like 0. That is negative 0.225 meter per second square. And that is the acceleration, we got it. So the answer is C1. Answer is C1. I hope so it's been clear. Now, along with this question, what I have to do it is this. First of all, equation of motion is important. You all know it. Then, how to use these equations. Always write the given, what is been to you given it. Then, according to the number of things. Now, if all the equations were not able to solve it, or we cannot put the values in all of the 3, then in that case, we have to take the 2 equations and then we have to solve it simultaneously. Okay, clear? So then we can just make the equations from 2 equations, we'll make the 2 equations, then solve it together, and then we'll get the answer for this one. But right now already the third one has been, we can easily put it. Simply done. Okay, so I think it's been clear. Okay, let's move to the next question. Let's move to the next question, number 7. A car traveling at the speed of 50 meters per second stops when the signal turns red. Okay. Calculate the distance traveled by the car before stopping if the reaction time of the driver is 0.5 seconds, 0.05 seconds. The brakes provide the retardation of 50 meters per second. See again, if you give, see just one thing, remember one thing. If they give you acceleration and that coming negative, so you need to write the retardation in the negative form, like negative 2 meters per second square. That's telling you the retardation. But if they used to write retardation, they just directly write 2 meters per second square. That means already it has been negative because this word is telling it's a negative. But if in case you are writing the retardation in terms of acceleration, you need to put the negative sign. You need to put the negative sign. I hope it's been clear. Yes. So now a car traveling at the speed of 50. So it's been traveling with the speed of 50 meters per second. Okay. Stops when the signal turns red. Stopping, that means V is 0. V is 0. Calculate the distance traveled by the car before stopping. If the reaction time, in how much time it just get reacted, the reaction time we have to give in. Okay, so that we can write at T reaction, that is 0.05 seconds. and the brakes are applied. After the reaction, the brakes has been applied and the retardation has been done of this, that is negative of 50 meter per second square. So here we have to do two things, and that is what? One, we have to calculate the distance when the brakes has been applied and how much how much distance just got stopped. And then the first condition, in the reaction meantime, the reaction time, that 0.05 seconds, he's been just getting the reacted towards it now. So at between that particular timing interval of it, the car should have moved something or some distance. So we have to calculate that. Remember this thing. So let's find out the reaction distance because of this type. So distance covered, that we can say reaction distance. So that is speed into time. Speed into time, simple. So 50 is been given and time is 0.05. So we'll get here now, that is how much? So if you put it x like, suppose 100, zeros cancel by 0, 5 ones are, and that is 2. Okay, so now when you divide it, you will be getting around 2.5 something. Yes, 2.5 meter it's been moved. The car has moved 2.5 meter. The car has moved 2.5 meter when he just when he just saw the red light and want to stop the car at that particular time. Then he applied the brake. Then he applied the brakes. So when he applied the brakes, so how much distance has been traveled? So we need to calculate the distance also. Now that is the S we have to travel now. So for that particular braking system distance, what we have to use? U we have, V we have, time is the reaction time. The total time is not given of the stopping, then distance. So that simply, again, third equation, V square, U square, 2AS. Okay. So let's divide into 2. Now let's see it from here. So V is 0. U is how much? That is 50 square. And plus 2. The acceleration is given minus 50. And that's the distance S. Simple. So let's do it. That is 5 5 the 25 and 0 0. Okay. Then this one will be, why I have written negative? Because it's been given the retardation. It's been given retardation. See, this said the retardation, so we are using negative sign. We are using the negative sign with it. Minus 100 S. So it will be like 100 S equals to 2500. 100 is equals to 2500. So here we will get now this S equals to 2500 upon 100. 0 0 0 0 cancel out. So we got 25 meters. So total distance now traveled. Total distance traveled. Total distance, how much it will be? When the reaction is being 0 point, that is 2.5. And finally at the 25 meter, when the car starts to stop at that particular signal. So it will be like 25 plus 2.5. 25 plus 2.5. Okay. So we'll get now what? That will be 27.5 meter. That's the total distance. So which option? Option number B. Clear? Okay, so like this we can solve the questions. Again, the equation of motions, one question has been there. Okay, so similarly, this always see what is given to you. If you're just getting confused, try to draw the diagrams in that case. But if not, then just try to write that given in the rough and start solving it very faster. You don't have to write it one by one. You just solve it directly also in the MCQs in the paper form, okay, when the objective type has been given. But yeah, for the school level, you have to do it like this only, okay? Clear? So let's do with the next question now. It was the easy one from the electric current, okay? So I'll just give you the basic part of the electric current also, and then we'll move to it. First of all, now it's been saying Nidhi has the two bulbs connected across the two cells in the simple circuit as shown in the figure. How can she make the bulbs glow dimmer? How can she make the bulbs glow dimmer? Okay, we can do it easily, no issues. See, two batteries has been given. This V1 and V2. Let's see, it's been given V1, V2. This is positive, negative, positive, negative. Now, if we have given the cell, this is a symbol of a cell. This is positive, this is negative. So it's been called at higher potential. This is the lower potential. Now if we have given like this, so it's called a battery. Positive, negative, connected here. Okay. We all know one thing. we all know one thing, that is the convectional current direction, the direction of current. The direction of current is always positive to negative. That is higher potential to lower potential. Always remember, the current will go from higher to lower. That means if in this condition we are talking about, the current will go in this direction. Okay. So suppose if the current is been going from higher potential to lower potential, okay, and that's the current I. So we have the electrons also, we have the electrons, and that will move opposite to the direction of current. That will move opposite to the direction of current. And how the current is being there? Why the transfer conductor is easily to transfer? Because they have, the conductors have the free electrons. Remember, conductors have free electrons. First of all, that's why. Now it's been saying she wants to glow the light dimmer. Okay, so what should she do? Replace the one cell with the piece of the chalk. Will the circuit work? No. Chalk is an insulator, bhai. Chalk is an insulator. It won't work. It won't work. Okay, the circuit will not work then. The bulb will not glow only. Replace one cell with the piece of the wire. This we can do. If instead of this one, we just use the piece of the wire, the current just it will be similar, so it will be the bypass here. So directly current will go. Okay. Replace one bulb with a piece of the wire. Replace one cell with the piece of one bulb with the piece of the wire. So if you replace this here, how it will glow? Low. No, it will be getting the more, because in the series the connection, the current will remain, the current remains same, but the potential changes for both of them. So no, it will not be done. Replace one bulb with the another one. Replace one bulb with another cell. Okay, another cell. It's saying use another cell here. That is also not true. You can replace the one cell with the piece of the wire, and through which what will be happen? You will lower the potential. You will lower the potential so that the bulb will glow dimmer. The bulb will glow dimmer. That is the one. Okay. Clear? That is the one. Just remember one thing from this question with the we can have the current electricity one. In series connection, current, that is I, remains same, but potential changes. Okay, just remember this part. Then sir, what happened in the parallel? What happened in the parallel? Okay, in parallel connection, current changes, but potential remains same. Okay. So this is a part 1. In the part 2, I'll try to bring the questions, previous one question which is being came in from the electric current one. How will you identify whether the circuit is in parallel or in the series? This we'll try to do it in the next one. Okay, let's go to the next question now, everyone. So now the figure shows the ring magnet X floating above the another ring magnet Y. This is because, see, you can see it here. This is the Y, this is the X. The one is been floating over the another, and how it's been done. So maybe you all have done or not. Most of you have done this also. We used to do what? The small toy car comes, which is a free one, no mechanism, nothing. Only the wheels they have. They used to slide over it. What we used to do? We put the magnet. One is from the north here, south here, and we bring the another magnet near to it. If it's of south and north only, this is south and south, so it will repel, the vehicle will move in this direction because of the repulsion. And if we change the polarity from north to south, it will start to come in this direction. So we give the motion by bringing the another magnet. Why is it so? Because it has the property that is the north and north, south and south, that is the like poles, and they repel. Okay, whereas we have south and north or south, we can say, that is the unlike, they attract basically. So they simply attract, nothing, done. So now this x and y has been one another is floating. That means one has been pushing the other one. That's why not getting in contact with it. Because the magnetic force is the force which is to show the attraction also, repulsion also. Right now it's been showing the repulsion case. Repulsion comes when the poles are like. The poles are like. So magnet x is lighter than y? No. Magnet y is more powerful than the x? No. The like poles of the both magnets are facing each other and they repel each other. That is the true one which we are getting it. The unlike poles of the both magnets are facing each other and they are attract. No, they will attract, they will be joined like this, x and y. But right now x is here, y is here, and it's been like bouncing like this. So if you find some ring, we can say the spherical or donut shaped magnets, you can just do it with the pencil, and also we have done that. Okay, so if you put it like this, it will work as a shockers. Okay, it will work as a shocker because the two magnets won't come together, and if you just put something, it will start to like bounce like this. If you just move this and give some motion into it, ऐसे ऐसे bounce करने लगता है वो. ठीक है? Clear? So this is the one. 10th question, everyone. Okay, so here we go with that question number 10th, and that's what? A student rubbed the piece of the silk over the balloon. Okay, over the balloon. That will be the last question we are doing it. Then in the next session we will doing taking the more. A student rubbed the piece of the silk over the balloon filled with the air. Okay, the student put the balloon and the piece of the silk down on the table. Which will most likely happen when the student moves the balloon and near the silk? Very easy. You all have done it. Take the scale, put it on your hairs. Okay, then bring the small sprimbles of the paper pieces, then bring it near to it, it will start to attract. And that's called to be the electrostatic force. That's called electrostatic force. Similarly, in these forces, you have the charges. Charges are of two types. One is positive, one is negative. Positive is called to be the proton. Negative is electron. So if positive, positive there, negative, negative, these are called like poles. They will also repel just like the magnet. If you have negative, positive or positive, negative, they are unlike. So they will attract each other just like the magnets. Okay, so this is the part. Now when you bring the silk and the balloon, so because of the friction, this rubbing one part, there are three methods of charging. There are three methods of charging. That's called, first is charging by friction. Another one is charging by conduction. And that is what we are doing. You are just touching it. You are just touching a charged body, bring to the uncharged, and you are touching it. And the third one, I am writing it here. Let it be here. Charging by induction. Charging by induction. So these are the three processes. Right now the process which has been working is the charging by friction. So when you just starts to move like this, rub the bodies like this, so one of the body will getting the charges and they will show it here. So one body will be getting positive and one body will be getting negative. Depending upon the material, the electrons how loosely bounded with it. So one of the body, see, suppose if I am having the 5 protons, 5 electron in this, and 4 protons and 4 electron in another body. If I used to rub both of them, so one of the body will getting the electrons from here, so one will become deficient of it, so it will be getting 5 proton here, and this will be getting 6 electrons. This will be getting 4 proton and 3 electrons. So this body become positive and this body will become negative. That is the transferring of the charges comes. Okay, so if one is negative, one is positive, when you keep it nearby it, what will happen? Negative, positive, what will we do? It will attract. So the balloon will flow toward the ceiling. No. The silk will fall toward the floor. No. The balloon will be attracted toward the silk. Yes, this is the one. This is the one. Either the silk will attract to the balloon or balloon will attract to the silk. The silk will be repelled. No, it will not repel. If they have the same charge, then it will be repelling it. But because of the friction, the electron has been moving from one body to another body. One is losing, one is gaining. The one who gains become negative. The body which gains electron becomes negatively charged, and one who loses electron becomes positively charged. Remember this. Okay, so we are going to do the more questions from this. Okay, so guys, that's, I think this is the one which we have done. Then the next we are going to do it, some more questions has been there. Okay, so I hope so these 10 questions along with the concepts from the previous course and all, I have taken it out in that this is a part 1. we'll try to do the more question in the part 2, okay, with the different logics, and also these logics won't come again with the different, like the resistance one, okay, the last part which has been there, okay, so we'll do it, okay. So that's all for the session, everyone. So again, this is Sachin sir from the Sri Chaitanya Institute of Learning, okay, and what we are doing, we are preparing for the scholarship examination, which will bring us the 100% scholarship, okay, then exciting gadgets, okay, and the thing is the main which I love it the most, that is the NASA trip, okay, and you have the cash reward also, okay, got it. So please do like us if you like it, you're getting the things clearly. You have, if you are not registered, please do register it, okay, because of the examination. So please like, share and comment, okay, and subscribe the channel so you get, and hit the bell icon, so what you can do, so basically get the notification for the others ones, okay. So just these are the dates which is very, very important for you all. These are the dates, 28th of September and 12th of October, which is very important. So you can just go get yourself registered on this one. Link is in the description. Okay. So it's a national level scholarship examination which is being given from grade 3 to 12, conducted by Sri Chaitanya. We all know it. Format is online and offline, and goal is to identify the reward and academic talent. And you have the lots of gadgets, NASA trip, exciting one. Okay, and 100% scholarship. Okay, so you can do the preparation for the your need of what the goal you want to achieve in your life, okay. So these are the things which we go. The dates, again the dates has been there, 28th, 26th, 12th and 10th. These are the different things. Test date 1, registration, test date 2, registration for test date 2, okay. Just remember these dates, these are very, very important dates, okay, because if you are preparing and do not the dates, then what the use of learning right now for this scholarship? Otherwise learning never waste. It always help you out. It never waste. Always help you out. Whatever you learn, I have learned the seed. I have learned the AutoCADs also. Should help me out in designing my home. So everything help you out, whether it's been from your relative or not. Because see, learning is very good. Whatever you are getting in, just learn. Okay. It help you out in every time, okay. So you got this timing has been there, so do like, comment, share and subscribe, everyone. So just follow us on the YouTube, Instagram, Google Pay, you can download the app, Telegram and the Facebook. So that's all for the session, everyone. Thank you very much. Thank you. Bye everyone. That's all for the session. I hope you have enjoyed the session. If you guys get the answers, do write it in the comments. Before that, just stop the video, do the questions, write the comments over it. If you have any other doubt or suggestion for us, you can just put in the chat box, okay. And in the next session, we will be doing the part 2, so don't miss it, okay. Don't miss the part 2, okay, everyone. So that's all for the session of it. Bye everyone. Good evening. Bye everyone.